only 5 households. Okay? And if you can do it for 5, you can do it for 150 million or 310 or 11 million or whatever it is. How many households do we have in the U.S.? How many people in the U.S.?
350 million.
Yeah, a little bit less, but not a lot less. 110 million households, give or take.
Sorry, who's the last person?
Pardon? That's Beth.
Thank you.
Beth. And let's say, and I've got my cheat sheet back in the wall there. So let's say that their household incomes are as follows.
You've been doing that the whole time?
No. See, I barely put these up.
Just noticed.
Yeah, I've not done it before. I knew we had so much to deal with tonight, Charlie,
Yeah.
that if I had to calculate it every turn, we'd never gotten through it. Okay? And that was not 50, that's 5,000, excuse me. And then 2,000. Okay? So they're not in rank order, but they're not too far off of it. I want to think about the level of inequality in this society. And I want to think about it graphically. So I'm going to think in terms of an XY Cartesian coordinate, but it's actually not flipped. I actually have my y-axis here, and I've got my x-axis going into negative space. I'm just going to telegraph the y-axis values to the other side, because for some reason I like to see it like this, and I have no idea why, just to be honest with you. Okay? Just the way it's done. So it's still a Cartesian coordinate, it's still an xy space, but in this space we've got percentage of households, and in this space we have percentage of total income. And we're going to look at quintiles because we have 5 different actors in our economy. So we can say each one of them has a household and they're each equal households, right? Maybe not equal income, but they're each households. So we've got 0, 20, 40, 60, 80, and 100. And we've got 20, 40, 60, 80, and 100. Percent of total income. Okay? Well, if we had a perfectly socialistic economy that worked, we would have, good grief, that's horrible. I can't even call that a quasi-straight line. Changed inflection so many times. Let me extend this out a little bit. And we're going to say that that's the line of inequality, such that 20% of our households would have 20% of the income. 40% of our households would have 40% of the income, and so on. So this is perfect income equality, which we're going to agree for this discussion, A, has never been attained for more than very, very brief experimental periods, and B, is non-productive. But whether you agree with that or not, we're just going to say that's observation. Okay? So we want to see how this grouping of households, perhaps, can be fit into this space. Okay? So the first thing I want to do is I want to reorder these households. And I'm going to go in rank order, starting with the lowest income first, and then up to the highest. So I'm going to take 2,000, and this is not correlated with John, I'm just now using the numbers. I'm abandoning the names. And then 4,000, 5,000, 7,000, 11,000, such that I've got 29,000 total household income. Okay? 2,000 of it is in the lowest quintile, 4,000 is in the second quintile, 5 is in the third, 7 is in the fourth, and 11 is in the fifth quintile. So that would be 2, 4, 5, 11, and the rest. But when we put it on the graphic, we're going to make it cumulative, okay? Because if we put it on non-cumulative, it would end up right around here, and that's not fulfilling the purpose of the graphic. So what's the cumulative? Well, here our cumulative, we're still at 2,000. Now we're at 6,000. Now we're at 11,000. Now we're at 18,000. And now we're at 29,000. And I've simply transferred the number over and then added the next to get the next. Add the next to get the next. Add the next to get the next. And so on. That's 1,009. Charlie, you should have solved my problem. So in order to construct this graphic, I need to know what percentage each of these are of the whole, right? Because I have to end up at 100% of the whole before I'm done. Okay. Well, that makes sense to me. I'm okay with that. So I can say 2,000 is 6.89%. 6.89%. If I calculated that with my calculator versus my cheat board in the back. Okay. So 2,000 divided by 29,000. And I can say that then 4,000, I'm not giving them cum yet, I'm just doing them individually. 4,000 is going to be 13.89%, roughly double. Okay? Maybe this was 84%, excuse me. And then the 5,000 is going to come in at 18.24%, I believe. And the 7,000 is going to come in at 24.14. And then the 11,000 is going to come in at 37.93. And these numbers are each percentages of the 29,000. So 2,000 divided by 29,000. 4,000 divided by 29,000. 5,000 divided by 29,000. So that we're not accumulating them yet. Well, if I do want to accumulate them now, I still have 6.89 here, or 84. But now 6.84 plus 13.89 is going to give me a cumulative number. And I can get that same number by taking 6,000, which is the cumulative income, and dividing it by 29,000, right? And so I believe it's going to give me 20.64, or something very close to that.
Your 18 it should be 17.8.
Is that right? 17
Because
point.
the sum of those is 101.0.
Yeah, I just couldn't read my own handwriting back there. 17.84. Excuse me. Okay. And then my next one, 11,000 divided by 29 happens to be. It's going to add it. So I've got 37.93. I believe something like that. Then I go at 18,000 divided by 29,000. I'm at 62.07, and then 29,000 divided by 29,000 is easy at 100%. Okay? So again, in this column, I've simply rank ordered the incomes in the economy. If I had 20 incomes in this economy, and I still wanted to do quintile separation or 5 different categories, I would still rank order all of them, but then I would add up the bottom 4, and the next 4, and the next 4, and the next 4. So I ended up with 5 groups, even though I had 20 households. If I had 100 of them, and I wanted decile segregation, or 10 separations, I would add up the bottom 10, and that would give me the bottom 10%. The next 10 would give me the next 10%, and so on. So you can do this with anything. I'm going to use quintile separation. I use it, I think, in the videos and the problem sets, and where you can see this on an exam, I'd use quintile on an exam as well. Okay? And so I've given the rank order. I've then accumulated them so I get to the total, and these two numbers ought to match, of course. And then in this column, I've simply taken the quintile's income divided by the whole each time. And in the next column, I've taken not the quintiles, but the cumulative income for the quintiles divided by the whole to get this number. Okay? So now, what do I do with them over here? Well, I see that the bottom 20% of my households has 6.84% of my income. So it's going to be right about here. And then not the next 20%, but the bottom 40% is going to have 20.64% of my income. So, right about there. And then the bottom 60% has a little bit less than 40% of my income, 37.93, right about there. And then the bottom 80% has 62.07% of my income, so it's right about there, such that I can now draw a relatively crude curve that happens to actually be 5 independent segments, straight line segments. This curve is the Lorenz curve, which, interestingly enough, was not developed to think about equality or anything in economics. It was developed to consider load factors by engineers for bridges. Go figure. And you can use this kind of construction to think about anything that you want to. I can use this kind of construction, and instead of having percentage household income, I can have something about education level. I can have something about hours work level. I can have something about our avidity to sports level. I can do all kinds of things with this. Okay? Just have to kind of think about it. Well, looking at that, Ben, what does that tell you about the income equality or inequality in this economy?
Regarding the straight lines, or?
Well, regarding this curve, my Lorenz curve that I formed. What's it tell you?
Well, just the lower, the smallest 20% of the households are just, have the smallest percentage of the wealth.
Yeah.
Or percentage of the income, and then it just shows the disproportion.
Yeah, it shows you that is disproportionate, but it doesn't show you a lot more than that unless you're very comfortable, which means unless you can compare it to something else. Oh, we're comparing it right now to the line of equality, right? That's the easy part. But we already knew it was going to be unequal. So, Stephen, is this good or bad?
We don't know.
I don't know. All by its lonesome, I don't know, right? I think that the best utility of a Lorenz curve is a comparative utility. What if we had a Lorenz curve like this for Americans in 1975, and now we had a Lorenz curve developed for American households in 2018? Would that be closer to the line of equality or further from the line of equality? Further from. And we can plot it if we have the numbers right. We'll just say it's down here somewhere. I don't know that it's that grossly different, but it's certainly different. It's probably that grossly different. No, that's not true. It's different. That we could look at two polities at one point in time, Brazil versus the United States. We could look at the African continent versus North America. We could look at white Americans versus black Americans. We could look at households in the 70s versus households in 2018. We could look at highly educated versus poorly educated. You can look at all kinds of things. In fact, you can put 2 and 3 of these, chart them on the same graphic, and you can have some really good, clear, comparative construction here. If you start to get many more than that, it starts to get really muddled, right? So recognize that the value of a Lorenz curve isn't just in being able to plot this, it's being able to plot one against another so you can see the differences. And you're probably either looking at 2 different groups at one point in time, or the same type of group at multiple points in time. Probably. Okay? So that's its value. Well, if I'm going to put that in an article, presentation, something like that, I'm going to have at least a quarter of a page so somebody can see it, right? Which is not cheap real estate in a textbook or in an article or a magazine, or if we're trying to display it on the evening news. It's going to take a few, 15, 20 seconds for people to look at it. So it's interesting. We can think of how to construct it, but all by itself it's a little cumbersome. Enters the Gini coefficient. That is a number But lets us think about this whole thing. We have to think about some of the limits for a minute. If the Lorenz curve demarks the space between A and B, A being the area above the curve, and B being the area below the curve, then the entirety of this relationship is A plus B, right? Holly, is the area of A plus B constant if this is our construction?
Yes,
How come? How do I know that?
it's always gonna add up to the same.
Is this always going to be 100% on the x-axis? Should the y-axis always be 100%?
Yes.
100% equals 1, right? This is a right angle triangle. 1 times 1 divided by 2, this is a constant at 0.50. I don't care what Lorenz curve, Gini coefficient, etc., construction you look at, that number, A plus B, must always be 0.5. Okay? If we were fortunate in a kumbaya kind of way to be on the line of equality, then A plus B would still be 0.5. It's just that A would be 0 and B would be 0.5. Okay? And it's conceptually possible to be on the line of equality. Yes, Louise?
How come equality is measured on a slope and not on a horizontal line?
I have no idea.
Oh.
Other than, in order to put it in Cartesian coordinates, it kind of has to be. This is simply the way that the Lorenz curve was developed, and so I'm happy to accept the construction. I mean, I can theorize, I don't know how else, unless you're going to use a spherical relationship, I don't know how else you would do it in a two-dimensional space.